All right, let's dive right in. Today, we're going to talk about something that sits at the absolute core of our digital world. We're going to look at how a modern programming language, Rust, is fixing a 50-year-old problem that most people don't even know exists.
You see, in the world of software, there's a kind of universal language. It's called C. It powers almost everything: your phone, your laptop, the servers that run the internet. But this foundation, this bedrock that our entire digital civilization is built on, it has a pretty dark secret. It's famously, notoriously unsafe.
A really good way to think about C is like the Latin of software, right? Almost nobody speaks it as their main language anymore, but its DNA is everywhere. It's the silent foundational layer, the lingua franca that lets all the other newer pieces of software actually talk to each other.
So how does it do that? Well, it's thanks to something called the K-application binary interface, or ABI. Just think of it as a universal translator. It's this super stable, low-level agreement that spells out exactly how different programs are supposed to connect. And for decades, it's the one standard that has just worked. But here's the catch. C gives programmers incredible power, letting them manage a computer's memory directly. The problem is, it offers absolutely zero protection if they make even the slightest mistake. And that turns writing C code into this constant, high-stakes tightrope walk without a safety net.
And we're not just talking about programs crashing when a developer falls off that tightrope. No, the consequences are way, way bigger than that. They are some of the most infamous global security disasters in the history of the internet. The danger comes from this whole class of bugs, this rogues gallery of memory errors that have given developers nightmares for decades. Because C trusts the programmer to handle everything, a tiny mistake can lead to things like a buffer overflow, where an attacker can literally hijack the program, or a use-after-free bug, which is just as scary as it sounds. And this goes beyond just technical issues. It's a human problem. For generations, software engineers have had to wrestle with these exact same terrifying bugs. It's created this palpable sense of collective trauma in the community. It's a huge mental burden to carry. And let's be clear, these bugs lead to real-world catastrophes. Let's open the evidence locker. Remember Heartbleed? A super simple C weakness, just not checking the size of some data, allowed hackers to steal passwords from millions of websites. Or Shellshock, where another simple mistake let attackers take complete control of servers. These aren't just bugs, they're systemic failures. So what do? Rewriting everything in a new, safer language is basically impossible. This is where Rust's brilliance comes in. Instead of trying to tear down that entire C foundation, Rust did something way smarter. It built a powerful and, most importantly, safe bridge to the existing C world. This bridge is called the Foreign Function Interface, or FFI, and it's basically a simple handshake. First, you tell the Rust compiler, hey, trust me, this C function exists. Then you tell it to speak C's universal language, that ABI we talked about. And finally, you just point the program to where the C code lives. It's an elegant, clear way for these two worlds to communicate. Okay, now to use this bridge, you have to use a keyword that gets a really bad rap: unsafe. Now, the big misconception is that this word just flips a switch and turns off all of Rust's famous safety guarantees. But that's not what it is at all. The reality is, unsafe is a contract. It's the developer making a promise to the compiler, saying, I have personally checked this tiny piece of code and I guarantee it's okay. It localizes responsibility, it doesn't just throw it away. And that's the whole philosophy. Instead of the C model where everything is one giant unsafe zone by default, Rust lets you create these small, clearly marked, auditable islands of unsafe code. Everything else, the entire rest of your program, exists in a vast ocean of provably safe code. It makes hunting for those dangerous memory bugs so much easier. And this brings us to Rust's true superpower. This FFI thing, it's not just for using old libraries. It's a Trojan horse. It gives us a practical, low-risk way to sneak memory safety inside the fortified walls of those huge legacy C and C++ systems, one little piece at a time. And look, this isn't just some theory. This is happening right now, at the highest levels. The biggest names in tech are all in on this strategy. Microsoft is rewriting parts of Windows in Rust. Amazon Web Services is building core cloud infrastructure with it. Cloudflare, Dropbox, they're all using this exact Trojan Horse strategy to surgically upgrade their most critical systems. I want to show you a perfect, concrete example of this in the wild. Let's talk about Dropbox. They had a really important service written in another language called Go that had a huge memory problem, and it kept crashing.
So get this. At its worst, just a single problematic function inside this service was eating up a massive 4.1 gigabytes of memory. It was just totally out of control, bringing the whole thing down.
So what did they do? Did they rewrite the entire service? Nope. Using that Trojan Horse strategy, they surgically replaced just that one bad function with a new version written in Rust. The results were, well, they're staggering. Memory usage dropped from over 4 gigabytes to less than 350 megabytes. The crashes just stopped. That right there is the power of this approach. And this really brings us to the big takeaway here. What Rust offers is a truly pragmatic, step-by-step way to finally fix the crumbling foundations of our digital world. You see, Rust isn't asking for some risky, all-or-nothing revolution. It's not demanding that we demolish everything and start over. Instead, it respects the legacy and the reality of C, and it just gives us the modern tools we need to reinforce that foundation, to make it stronger and safer, piece by piece. And that leaves us with one big, exciting question to think about. With this powerful and proven strategy for making things safer, what critical, vulnerable part of our digital lives is going to get a Rust upgrade next?